Welcome to Cap 2 of Math 1610. In this problem, we are given 3 trains of squares in a sequence, shown here by Figure 1, Figure 2, and Figure 3. And these squares are made up of toothpicks. So we'll go ahead and start counting the number of toothpicks in each figure. For Figure 1, we'll go ahead and write Figure 1. The number of squares is 1. As you can see, 1 square. And the number of toothpicks is 1, 2, 3, and 4. That is for Figure 1. For Figure 2, we'll do the same. So it's Figure 2. We have 1, 2 squares. And counting the toothpicks, 1, 2, 3, and 4, 5, 6, 7. 7 total toothpicks for that figure. And for Figure 3, we'll do it in a bright red. 1, 2, 3 squares for Figure 3. And my number of toothpicks, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We'll continue to do it with Figure 4, where we have figure number 4. The total number of squares is 1, 2, 3, and 4 squares. And the total number of toothpicks is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're trying to find a pattern in the number of toothpicks because the initial question is find a formula that determines how many toothpicks are in each figure. As we populate our table, we recognize that our number of toothpick increases from 4 to 7, so it increases by 3, and then from 7 to 10 is another jump of 3, and from 10 to 13 is another jump of 3. So it seems like every time I add a square, I increase by 3 toothpicks. So let's go ahead and try to see how these 3 toothpicks are added on each figure. As we increase from Figure 1 to 2, 3 toothpicks are added. As figure increases from 2 to 3, 2 to 3 squares, another 3 toothpicks are added. And as Figure 3 passes from 3 squares to 4 squares, another 3 toothpicks are added. Let's see if we can observe this pattern in our figures. So we start Figure 1 with 4 toothpicks. Our Figure 2 has those same 4 toothpicks, plus we add 3. We add 1 toothpick. We add a second toothpick. And we add a third toothpick. So to get from Figure 1 of 1 square to Figure 2 of 2 squares, we add 3 toothpicks. 1, 2, and 3. So it would seem like as the figure increases in squares, we would add this train or chain of 3 toothpicks. So we do that for Figure 3, because Figure 3 has 3 squares, so we add 1 chain of those 3 toothpicks to make for that extra square, and we do that for Figure 4 as well. So we start observing that our train of squares is really a chain of 3 toothpicks that add on to each other. So we can see how Figure 4 has 3 toothpicks for one square, 3 toothpicks for the next square, 3 toothpicks for the next one, and 3 toothpicks to make that fourth square. So we have really a chain of 3 toothpicks 4 times plus that initial toothpick. And it becomes very evident that each square uses the previous toothpick to make the square with the 3 added toothpicks. We observe this as well for figure 3 that has 3 toothpicks, another 3 toothpicks, and another 3 toothpicks to form the 3 squares. The same goes for figure 2, 3 toothpicks, another 3 toothpicks, with that initial white toothpick makes for 2 squares. And this pattern of 3 toothpicks is also observed in figure 1. Three toothpicks and that initial toothpick make for square 1 in figure 1. So now that I've drawn the 3 toothpicks that are added as each figure increases, I can see a pattern in my drawings. So I feel confident to draw figure 5 in this way too. Since I notice that I can start with a toothpick and add chains of 3 toothpicks as my figure increases, meaning as my number of square increases. So I'll go ahead and start with my first toothpick for figure 5. Since my figure 5 has 5 squares, I'll make sure to add 1, 2, 3, 4, and 5 groups of 3 toothpicks to make my 5 squares. 1, 2, 3, 4, 5 squares for my figure 5. I'll go ahead and input my data into my table. So figure 5 will have 5 squares, and I know that this is the same as the number of toothpicks in my figure 4 plus the 3 additional toothpicks. So that will be a total of 16. So this would be my figure 5. And I definitely am observing that I'm ready to do a formula on this. Hold on, so 16 and figure 5, we have it up there. So I'm ready to start thinking of formula, how I can express this mathematically. So I could start by saying that the number of toothpicks is equal to something, right? So my T of n is going to be equal to something. So I'll bring this formula down here. The formula that we're going to start to make up with the information that we have. So I can start to observe that, let's say for figure 5, if I want to count my toothpicks, I can start by counting my first toothpick. So 1 plus, I'm going to switch to blue, so my first group of 3 toothpicks, and then my second group of 3 toothpicks, plus my third group, my fourth group, almost put a 4 there, plus 3, remember, is 3 toothpicks that I'm adding, and then my fifth group of 3 toothpicks, for a total of 3 plus 3 plus 3 plus 3 plus 3. That is 15, plus that 1 is 16. So I'll go ahead and make sure I keep my 1 in the white color, plus the 15, for a total of 16 toothpicks, like our table shows. So now that we've determined the answer, we see that we got it by adding 3 5 times to get the 15th, plus that initial toothpick. So a way to simplify our addition would be to realize that repeated addition is actually multiplication. So we have 1, 2, 3, 4, 5 groups of 3. So we have 5 times 3. So the total would be that 5 times 3 plus that initial toothpick. And we see this pattern also for figure 4. So for figure 5, it's 5 times 3. So 1, 2, 3, 4, 5 times we add 3. For figure 4, 1, 2, 3, 4 times we add the 3 toothpicks. For figure 3, we're going to add the 3 toothpicks. We're going to add them 3 times. So for figure 3 it would be 1, 2, 3 times 3. For figure 2, it would be 1, 2 times 3 to get the number of blue toothpicks. For figure 3, we said it would be 3 times the 3 toothpicks. For figure 4, it would be 1, 2, 3, 4 times. So 4 groups of 3 toothpicks. And for figure 1, we would have 1 group of 3 toothpicks. And then of course we have that 1 toothpick that adds onto these toothpicks, right? For each, we can't forget about that 1 toothpick at the beginning for each, right? Let's put this one up here. So we can go ahead and start our formula. We know that we're always going to have that constant of 1 toothpick, right? That 1 toothpick. And we're going to add that 1 toothpick to my groups of 3 toothpicks. And then for adding our groups of 3 toothpicks, we start to see a little pattern. So if my figure has one square, so if it's figure 1, I have one group of 3 toothpicks. And then if my figure is 2, so I have 1, 2 squares, I am going to have 2 groups of 3 toothpicks, and so on. Let's try. So my figure 4, I will have 1, 2, 3, 4 squares. So I have 1, 2, 3, 4 groups of 3 toothpicks. So 4 groups of 3 toothpicks. So it seems like my number of squares, which represents what figure I'm on, so 4 squares, figure 4, is the same group of 3 toothpicks that I add in order to have that train number of squares. So let's go ahead and write it out for, let's say, figure 4. I have 1, my initial toothpick, plus 4 times so 4 times 4 groups of my 3 toothpicks. For my figure 5, I will have my 1 initial toothpick, this toothpick right here, plus 5 groups, 1, 2, 3, 4, 5 groups of 3 toothpicks, because we have 1, 2, 3, 4, 5 squares. If we continue to do this for my 3, so for my figure 3, I can say I have my 1 initial toothpick, plus 3 groups of 3 toothpicks. Here I've already done the example for the formula for 1 square, 2 squares, 3 squares, 4 and 5, right? So we can name our figure number or square number an arbitrary letter, right? So let's go ahead and name it n in accordance with our figure n. So n times 3 plus my constant toothpick of 1 will give us a formula of 1 plus n times 3, right? And we can write this out by saying t of n, and then we'll write 3 times n multiplication, right? And 1 plus, and as we know, we want to put our constant last and our variables first. So then we can conclude that our formula for any given figure, so for any given squares, is the total toothpicks will be t of n equals 3n plus 1. So I really hope this demonstration explains thoroughly how we obtain the formula Tn equals 3n plus 1, and how this formula relates to our train of squares. And also knowing that this formula that we found works for any given train of squares. So for any n figure, we have that the total toothpicks equals 3 times that figure, or 3 times that number of squares, plus 1. Thank you for listening to this audio and this demonstration of Cap 2 for Math 1610.